Adding and subtracting rational expressions is a little bit more complicated than just multiplying or dividing or simplifying rational expressions. But the process is very similar to the process of adding or subtracting regular fractions with whole numbers for the top and bottom. The process is essentially the same. So then let's review the process with two fractions, and then we'll add in the variables. All right, so what is the process? The first thing is you need to find a common denominator. If the denominators are different, you have to find a common denominator. To find the common denominator, you have to find the least common denominator, which is the least common multiple of those two numbers, 6 and 4. So basically, you think of the smallest, the smallest number that fits both 6 and 4 as a factor. If you think 24, well, 24 is a common multiple, but it's not the least common multiple. 12 is the least common multiple. 12 is the smallest number for which 6 and 4 are factors of it. So that means 12 is the least common multiple. What you want then is to convert both fractions to new fractions that have 12 as a denominator. All right, but how about if the numbers were big, the numbers in the denominators were big? It would not be then so obvious how to find the least common multiple, right? With small numbers, it is easy to just take a moment, think about it, and come up with 12. But if the numbers are big, it is not very obvious how to do that. Well, the process is as follows. If you don't know how to figure it out because the numbers are not so easy, what you need to do is take each of the denominators and factor it. So, for example, 6 factors as 2 times 3, and 4 factors as 2 times 2, 4, 2 squared. Okay, and then you're going to, for the least common denominator, you're going to write the different factors that you see without any exponents, So, for example, for 6 and 4, these two, I see a 2 times 3 for the 6 and a 2 squared. So the different factors that I see are 2 and 3. These are going to be multiplied, 2 and 3. You ignore the exponents for now, 2 and 3. So the different factors I see are 2 and 3. Then you're going to go back, and for each of these factors that you wrote down, you're going to choose the biggest exponent that you see. So for the 2, here is a 2 to the 1 and a 2 squared. So the big exponent that I see is a square. So I'm going to choose that exponent. And then for the 3, well, I only see 3 to the 1. So that's it, 3 to the 1. You multiply these things out, and that is your LCD. What is 2 squared times 3? 2 squared times 3 is actually 12, which is precisely what we had come up with. So in general, that's the procedure for finding the LCD if the numbers on the bottom are not really small or easy. Okay, and that's the procedure that I did right there is what we're going to follow in general, that I wrote down here, all the steps. But that's the procedure in general, even when there's variables involved. All right, once you have the least common denominator, you want to rewrite the fraction so that they have now this new denominator, in this case 12. So for this one to convert 5 over 6 into something over 12, you multiply top and bottom by 2. So I multiply by 2, top and bottom, and then this is going to become a 10. And in order to go from a 4 to a 12, I need to multiply by 3, top and bottom. So I multiply by 3. And if I multiply by 3, I'm going to get a 9. And once the denominators are the same, you can just subtract across the numerators. 10 minus 9 is 1. So the answer is 1 over 12. All right. Okay, now let's do the same with um, rational expressions with that have variables in them. Okay, here's the first one. Okay, so you see the denominators are not the same. We need to find the least common denominator. All right, so the procedure is you're going to factor each of the denominators. So 6x squared, that factors, you factor the coefficient, so that is 2 times 3, and then you have the x squared. Then 3x to the fifth, that factors as just 3 times x to the fifth, and then 2x to the third, that just factors as 2 times x to the third. So the least common denominator is going to be, first, you write all the different factors without exponents, without any exponents that you see. So I see a 2, I see a 3, and I see an x, ignoring exponents. Then you're going to go back and for each of these factors, you're going to choose the biggest exponent that you see. For 2, I don't see any exponents other than the invisible 1 there, so that's it. For a 3, same thing, I don't see any higher exponents except the invisible 1. But for the x, I see that 5 is a big exponent. So I'm going to put here a 5. And that is the LCD, that's it. Now, you simplify this. This will be 6x to the fifth. All right, and that is the LCD. Okay, so now that is the new denominator that we're going to want. We're going to change each of these three fractions into new fractions that have 6x to the fifth as the new denominator. Okay, and now we have to think, what do we need to multiply each of those fractions top and bottom so that they become on the bottom 6x to the fifth. So starting with 6x squared, by what do I need to multiply that to get a 6x to the fifth? To get a 6x to the fifth, you need to multiply this one by x cubed. So whatever you do to the bottom, you do to the top. So that means I need to multiply that by x cubed. So the top then is going to become 4 times x cubed, which is 4x cubed. So that's what I'm going to write here. That's going to become 4x cubed. And you multiply top and bottom by x cubed. Now, the next one. How about the next one? The next one is 1 over 3x to the fifth. And I need the denominator to be 6x to the 5. So what am I missing? We're missing a 2. And we're not missing any x's because we already had 5 and we need 5. So just only the 2. So whatever you do to the bottom, you do to the top. That means on the top, we're going to have a 2. So that's going to be 2. And lastly, for this one, 5 2x cubed, if I want it to be 6x to the fifth, by what do we need to multiply the top and the bottom to get 6x to the fifth? Well, I need a 3. Indeed, I need a 3 to get a 6. And then we need an x squared to get x to the fifth. So I need to multiply top and bottom by 3x squared. If you multiply the top by 3x squared, that's going to become 15x squared. So that's going to become 15x squared. Okay, so 15x squared. And now all the denominators are the same. So now we just subtract or combine things across. But there's nothing else, there's nothing to combine here. There's no like term, so I'm just gonna write everything. 4x cubed and minus 2 plus 15x squared. We normally remember that we normally write things in order. So even though this is correct, I would probably write it in descending order. So I would write x cubed plus 15x squared minus 2 over 6x to the 5th. That looks a little bit better because it's in order. All right, so that's it. Okay, so that is the procedure. Okay, let's do another one. Let's do this one right here. So first step is factor each of the denominators. So x squared minus 9, that is a difference of squares. So that's factors as x minus 3, x plus 3. Factor x plus 3, well, there's nothing really to factor there. That's just itself. And x minus 3, that does not really factor either. So that's just x minus 3. So these are the three denominators factored. Now for the LCD, you're going to write down each of the factors, each of the different factors without any exponents. So I see an x minus 3 and I see an x plus 3. And then you're going to go back. Remember, you have to go back and choose any exponent. For each of these factors, choose the biggest exponent that you see. But there's not really any exponents here, so I mean that means we're done. There's neither exponent other than a visible one for each of these. So that's it. The LCD is going to be this. Okay, so now we're going to convert. So let's do it here. We're going to convert each of these fractions, rational expressions, into new fractions that have this as a denominator. Okay. Oops. So let me just copy this for my convenience here. Instead of writing x squared minus 9, I'm going to write it in factored form. Okay, so instead of writing x squared minus 9, I'm going to write it in factored form. It's a difference of squares, so the bottom factor is x minus 3, x plus 3. And I'm doing that because it's going to make it easier for me to see what is missing when I'm trying to complete it to get the new least common denominator. Okay, so I'm just copying the problem here again for my convenience. Okay, so that's the problem, the same problem. Haven't done anything yet. Okay, now we want all the denominators to be this. So I'm going to convert each of the three fractions into new fractions, I mean rational expressions, that have this as the new denominator. So each of them is going to be converted. Okay, and then you think, what is missing? Let's go one by one. What is missing from this one to get this as a denominator? Nothing is missing, right? So that means do nothing. So that one is good to go. How about this one? You see that what is missing is an x minus 3. So that means we multiply bottom by x minus 3 and the top by x minus 3. So you need to put here x minus 3. So I'm going to write it kind of small. Here x minus 3 and x minus 3. So the top is going to become just 1 times x minus 3. You don't have to write the 1. So just x minus 3. And then in this one, what is missing is the x plus 3. What is missing here is an x plus 3. So that means this one is going to become 2x plus 3. Okay. Now all of them have the same denominator, and all you have to do is now combine the numerators across. So do just not worry about the top. Okay. So this is gonna, I'm just gonna write everything now for single big fraction. This is gonna be x minus 3, x plus 3. So the top is 2x minus x minus, so I have this minus, parentheses x minus 3, minus 2, x plus 3. Okay, now let's simplify. This negative has to be distributed, so this is going to be minus x plus 3, and then distributing here. This is minus 2x minus 6. And then just copy the bottom. And then combine like terms. So 2x and this negative 2x cancel each other, so we only end up with just this negative x. So you have just negative x on the top. And then the 3 and minus 6, that would be minus 3. So you have on top negative 3 minus negative x minus 3. Aha. So we have that. And remember that you always have to think, is this really simplified as much as possible before you give the final answer? And you look at that, it looks especially similar to one at the bottom, but comparing directly, none of the factors in the denominator is exactly the same as the top. So you cannot really cancel anything. However, if you remember the trick of factoring out a negative to see if that helps things, it actually does. So if you factoring out the negative, the top becomes negative parentheses x plus 3, and now you see that you can cancel an x plus 3 factor. And what remains is a negative 1 on top and an x minus 3 on bottom. And that would be the answer. Okay, let's do a couple more examples. Here's another one. 4 over y plus 2 minus 1 over y plus 1. I suggest that maybe you can try this one on your own before continuing. Or if you don't want to, maybe try the last one, but probably try one or just wait. Okay, so let's go over this. So what is the procedure? The procedure is factor each of the denominators. So the first denominator is y plus 2. You cannot really factor that. Next denominator is y. You're going to really factor that. And then the last denominator is 1. Because this is like 1 over 1. You cannot really factor 1. So that's it. So now we can immediately write down the LCD. You write down all the different factors. 1, which you don't really need to write that. Y and y plus 2. And then you go back and choose the highest exponent for each of the factors. There's no exponent, so that means we're done. That is the LCD. Okay, and then you go back and convert each of the three fractions into new fractions, into new rational expressions that have this as the denominator. So we're going to have three rational expressions that have this as their denominator. Okay. The first one, what is it missing from the bottom? It is missing a y. So that means you multiply the bottom and the top by y. So if you multiply the bottom and the top by y, the top is going to become 4y. Now move on to the next one, this one. What is missing from the bottom? It's missing a y plus 2. So that means you multiply the top and bottom by y plus 2. So it's going to be 1 times y plus 2, which is just that. You don't have to write the 1. And lastly, the last one, which is like you have to think of this as 1 over 1, right? So the very last one, both are missing, the y and the y plus 2. So the top is going to become 1 times y times y plus 2, and you don't have to write the 1, so just write y times y plus 2. Okay, now all of them have the same denominator, and I can just write it as a single big fraction and just combine the numerators across. So this is going to be 4y minus y plus 2 plus y plus 2, and then all we have to do is simplify as much as possible. So this is going to be 4y minus y minus 2 plus y squared plus 2y all that over y plus 2. And then lastly, let's combine like terms and put everything in order. So y squared, I have 4y minus y, that is 3y. 3y and 2y is 5y, and then minus 2. All that over y plus 2. And then we're done. Now remember to always think whether we're really done. You should try to factor the top, but you will see that it doesn't really factor. So it doesn't factor, so that means you cannot simplify this anymore. And that's the end of that story. Okay, you should try that one. So you should pause the video and give it a shot to see if you really followed along. So now let's do it. So first step is factor each of the denominators. So the first denominator is y squared minus 2y plus 1. That factors actually as 1 minus y minus 1 squared. Y minus 1 times y minus 1. Y minus 1 squared. The next one is 1 minus 1. That does not factor anymore. So it's just y minus 1. And y plus 2 does not factor anymore. So it's just y plus 2. And now we're ready to write down what is the LCD. The LCD is you're going to write each of the different factors that you see without any exponents. So I see a y minus 1 and a y plus 2. And now you go back and choose the highest exponent that you see for each of the factors. For y minus 1, I see as the largest exponent I see is a 2. And then for y plus 2, there's nothing higher than just 1. So this is going to be the LCD. Okay, and now we write each of these fractions as new fractions that have this thing as their common denominator. First, I'm just going to copy the problem for convenience, but when I copy it, instead of writing the denominator like this, I'm going to write all the denominators as factors. So instead of writing this, I'm going to write this as the actual denominator. Okay, so I haven't done anything. Just copy the problem, but with this denominator in factored form. Okay, now we're gonna compare and think what's missing. I need this to be the new denominator. So my new denominator is gonna be this: y minus 1 squared, y plus 2. Same for the next one. And same for the last one. Okay, what is missing from this one is a y plus 2. So that means you need to multiply top and bottom by y plus 2. So top and bottom by y plus 2. So the top is going to become y plus 2. So I'm multiplying the top by y plus 2. This one, I have, what is missing? I'm missing a y minus 1, because I need to have y minus 1 squared, and I already have one, and a y plus 2. And for the last one, what is missing? The y minus 1 squared. So, okay, I need on the bottom y minus 1 squared, y plus 2. I already have the y plus 2, so I'm missing the y minus 1 squared. Okay, so now we can write everything as a single fraction. And just worry across just worry with the numerator. Worry about the numerator. So I'm just gonna copy this, and it's gonna take a minute to simplify this. As long as you're careful, that's not really hard. It's just multiplying polynomials. So this is, let's distribute here. This is y times y, and then y times 2. This is y squared plus 2y. Then I'm just gonna leave the 2 for the end, for last, and then foil these two. Okay, so I'm basically ignoring the 2 for a second and foiling that out. So ignore that 2 for a second, foil that. You're gonna get y squared plus y minus 2. And then I'm squaring this. You can use a shortcut. Ignore the 3. We'll do that last. And then squaring this is you square the top. Either you write it out twice in FOIL or use a shortcut. Square the top. Square the first. Square the second one. There's a term in the middle that is multiply both of these, y times negative 1, and double it. Y times negative 1 is negative y, double, that's negative 2y. Okay. Now let's distribute the 2 and distribute the 3. Okay, distributing the 2, you're going to have minus 2y squared minus 2y plus 4, and then plus, distributing this 3, plus 3y squared minus 6y plus 3, y minus 1 squared, y plus 2. Okay, so distributing this, you get negative 2 squared minus 2y plus 4, 3y squared minus 6y plus 3. Okay, now combine any like terms and see if you can simplify any more, and that would be it. Um, Combining the y squared terms, y squared minus 2y squared is negative y squared, and 3y squared is 2y squared, so that would be 2y squared. Now let's combine the linear terms, 2y minus 2y, the 0y, and then minus 6y, that would be minus 6y. And then the constant terms is 4 and 3, that is 7. And then on bottom we have y minus 1 squared, y plus 2. All right, and then think whether you can factor this. If you cannot factor this, then it's over. And if you can, then you should try to factor it and see if you can cancel. This one doesn't actually factor anymore, so that means this is really it. That is the final